Hi everyone, welcome to our practice exercise 3. And this exercise we will mainly practice on the SQL queries, views and aggregates. So we will use the background of the following schema and in all the practices. So we have the host, session, access, and access is a weak entity which is part of the session, and session and host are both of them are the entity. Then here we got one-to-more relationship, one-to-many relationship, so we do not need a separate table to store the relationship for this relationship. And session got ID and complete. Host got its primary key with ID and other attribute called IP address and host name. And the access this entity, we got the session as which is the primary key of this weak entity, and the others are the course page parameters, number bytes, and the accurate time. Okay, then the following relational schema will be used all throughout all the following questions. So let's have a look. First, the table host, we create such a table and ID, which is an integer, and it is the primary key. IP address, which is a varchar, the character, the string with varied lengths, and we set a constant called its unique. That means none of the IP address can be duplicated, so no duplication in the whole column. And host name is a varchar as well, and we give the maximum length of this varchar 100. The second table we call it session, and session is entity as well. IT host complete, and we have the primary key as which is ID, and because we have one-to-many hosts here, so we have a foreign key saved in the session table that is referenced from the primary key of the host table. So we do like this. So the host, which is a foreign key and complete, which is balloon type data and represent true and false, true or false. And then the third table we got is accesses. So the session here is the primary key, and because it is a weak entity, so the primary key of the session, this table, will be also included in the primary key. So final primary key is combination of the session and the sequence together. And the foreign key, because here is still a one-to-many relationship, so the foreign key session of the session ID will be stored in the access table as well. So that is the session foreign key, and combined with sequence, that is the primary key of the access, and the other are the course, which is an int. Page is a varied character, maximum length of 200, same as parameters. And accurate time is a timestamp to represent the time, and number of the byte is still the integer. Okay, so all the data have been already saved here, and we can populate the data in by use the following command. Let's set up the database first. So we use P1 to start our database, and we create a database. Let's call it weblog. Then we need to use the files in the weblog zip, so we need to unzip the file first. So we unzip the file. It's asking for, because I have already got it here, so it asks me I want to replace it or not. So now let's have a look. We have all of the sessions.sql, weblog.sql, schema.sql here, and we need to execute the schema SQL first, then the host SQL, then the session SQL, and the last one is exercise SQL. Each of them represent our table respectively, and the exercises got a lot of data inside, so it will take a longer time than the others. Each of them is in Z01 means there is a one tuple have been already successfully inserted. Okay. An alternative way for achieving the above is by we can not only access the schema.sql outside PostgreSQL platform, so we can also get into the start the SQL and into the new mode in the SQL mode. This means the PostgreSQL mode, it always start with our equal and hash sign, and then we got slash I and typing schema.sql. That means we now to execute the schema.sql. So this command is exactly same as this one. It's just different grammar and different language. Okay. And another way to do that, not another way, is like if we want to set up the SQLite database, then we need to do like this. So SQLite 3, let's create such a database first. Then we need to use .read. This is a common grammar for SQLite. .read for this schema, because I have already created this before, so it said it already exists. So similar with the following comments. Then the last, if we want to quit this mode, just type .quit. Okay, so there are different usage for the SQLite and the SQL. Now we want to check what we have now in the database, in the weblog database. So we use a /d to say sorry, I typed the wrong thing. /d. Okay, so the /d means I want the description of the whole database, so it will list the schema of this database, list all the relations. So now we can say 3 tables here, and the owner is me. This is coming from the user, so my user is coming from here. And all of them are the public. That means is public is generally can be accessed. And the next step is we check what we have and how, if we successfully insert the value in the host table. So we select the const star. Const star means we select everything. We count the number of the record in the host. So it's the count equal to 2213. So that means we got 2213 records in the host table. Similarly, we got 4610 records in the sessions table, and a lot of over 50k record in the access table. Okay, so that is how we normally check what we have in the database. And then if we want to quit this mode, we use /q. Then let's start the exercise today. We will give you a template you can access by here. then it will help you to create a view. Then in this view, you use the select, then by select star from this QN will return the full result. So let's start on the real question. The first question: how many of the page exercise occur on the 2nd of March? So in this question, we assume that it's in year 2005. We will update the question later, and so the accurate time, the access time was saved in access time or saved in the accesses table. So in the access table, we want to filter on this specified column called exercise time. Then we count how many records are satisfy this condition. So let's check. Okay. Let's look at the answer. So first, we select the count of star. That means we count all the record number of the record in the access table. For if this record satisfy this condition, that is access time is larger than 2003 32 and less than 2005 before this new date. We can also use the between and, but now we use the larger sign and the smaller than sign. Okay, let's check what we will have in the first question. We use select the star from question 1 and okay, so here we got there are over 20,000 exercise in this specified day. Right. Question 2. How many times was the main web CMS message board search facility used? You can recognize this by fact that page contains message board and the parameter string contains state equal to search. So we want to check if the exercise page is like message board, and also the parameter should like state equal to search. So the page is a very long string. We set here in the schema. The page is a long string and maximum length equal to 200. So in this question, we want the page contains message board and the parameter string contains state search. So we'll do like this. Let's check if we get the correct answer. Here, this percentage sign is a wildcard. That means it can be matched to unlimited string, unlimited characters here. So it starts with message board and parameter contains the state equal to search. Okay, and here if you get 1 as a count, you're probably picking up a search on one of the web GMS message board, which is not use the main web CMS message board. Okay, so that is the difference. Okay, then question 3. On which distinct machines in the toolbar lab will web CMS session run that will not terminate correctly? That means which is uncompleted. So we will say the result look like this. The session complete attribute will tell us whether the given session was complete or not. So we will select the hostname contains tuple and with any number after that, and we cse.unsw.edu.au, and then complete is not true. So we will do this. So first we will select the host name from the host table, and because we also want to check the sessions is complete or not, so we will join these two tables together. This is the how we join these two tables together, and this is the indicator to indicate whether it's complete or not. Then the host name like indicate which is content tuple as the heading, and end with cse.unsw.edu.au. Then let's check this result. Okay, so I forgot our semicolon here, so it's returning an error. But okay, after we've add a semicolon here, then it said the result. It will show the result here. Okay. Then question 4: what are the minimum, average, and maximum number of the bytes transferred in a single page exercise? Produce all these three in a single tuple. Make sure they are all integers. So first we need to select all of these three questions, all of these three numbers. So they are the minimum number of bytes, the maximum number of bytes, and bytes are always integers, so we do not need to convert the data type. But the average may be not maybe not integer, because the average always return and with the float, so we will convert it into integer, and then we return the final result. So it will say we got the minimum is 0 and max is over 400,000, and average is around 3,000. How many of the session will run from CSE host? A CSE host is one whose hostname ends with CSE. Ignore any machine whose hostname is unknown. So we need to do our include of wildcard and put here. We select star and the host, make the host name end with the CSE address. This means we can have any length of the character before this ending. So we will have, okay, so then we will count the number of the session we have here. So because we count the number of the session and host, that means we need these two tables together. So we join them together and then return the count. Question 6. How many of the sessions will run from the non-CSE host? A non-CSE host is one whose hostname not ending this one, and ignore any other hostname is not known. Okay, so similarly we will have like this one, but this one will filter out this one, so it's not like this ending, right? Then that's it. Okay, so we will have 2000, not like this ending. Question 7. How many page exercise were there in the longest session? So we first select the longest session. We first get the session of session length. So that means we select the session and count the number as the length. So count how many record in each session. Then in the longest session then we select the longest section that by use a subquery to select the maximum length from the session length and get the session length returned. Let the length equal to the max length we selected. Okay, so we will have this result. Question 8. Each exercise tuple indicates an access to a single WebCMS page. Then we need to produce a list of pages and their access frequency. That is how many times each is accessed. Do not use order by or limited in the view, so we will use the count. Right? Okay. So let's create our frequency count. So here we got a page and a count from the exercise. Then we group by page this column and order by the count descending. That is. So here it asks us do not use order by in the view because when we select from this question, it will have an order by outside, and also it set the limited 10, so it will return whatever you order by inside your view or not. The result will always order by the frequency and by a descending order, then give the top 10 record. So let's try to execute this result. It will return the top 10 most accessed pages. 9. WebCMS is divided into modules, while the PHP script for each module is contained in subdirectory. So we want to get the module name from the fifth component, and then count their access frequency. The module name is like this, so it will be like notice, course. So they are the fifth component from this from the script name, from the page's name, and also we need to get the access frequency. Okay, so we will use the regular expression to get this substring. So first, we create a view to get the substring from this page name. So here, the session include the session name and the sequence, and then we get the substring from the page. This means the first head means match the beginning of the string, and the following means matches one or more characters that are not a forward slash. Okay, so for example, in this string, it will get you the first part, the notice, and not include the first slash. So that means indicate this slash is our a separate indicator. Okay, so after we separate this substring, then we will create our counter. So now we create the Q9 to count the number of each page's access frequency. Okay, because we have the order by in the final select clause, and also the limit 10 for select the top 10 record. So that means we do not need to have the order by or limit in the wheel when we practice. Okay, so it will get the first component here, the module's name are all listed in the first column, and following by their frequency. And if you want to learn more about the string operators and regular expressions, you can access these two pages for more details. And And this script, question 10, the script that maps the web log into relation tuples isn't perfect, as it proceeds to any session that have no corresponding exercise. Write a view to print session ID for such a session with no corresponding exercises. So that we will select all the IDs in the session table and filter out any ID not existing in the exercises, right? If not in this list, then that means it do not link to any exercises. So let's test the result. Is that the 3 sessions do not have any exercise. Question 11, which host will not involved in any exercise to web CMS? So we will select the host name and which not involved in the session table. So we select the host name from the host and do a left join. Do a left join on the session table and group by the host name. That means we select we select that everything got a record, at least one record. We select all the sessions, at least one record in the host name and group by the host name. Then having a count, we filter out any kind of such a session without any exercises. So let's check. So that means these 3 web are not got any exercise. So notice that the having always after the group by. If it's a simple condition, then we will use the will, but only the condition that we have to apply after the group by, we will use having. Otherwise, we will use will coming after from. Okay. So here is we provide a sample solution for the previous question. And then we can try something in the SQLite in here. So here is the interface of the SQLite 3. It is not as friendly as PLSQL. It doesn't format its query result quite as nicely, so that's why we mainly use PSQL in this course. And to get something vaguely similar to PSQL, you will need to run such a command, so to change the output format. And also it does not support the paginate output for the long query result. So that means if the result like this, still remember that we can go to the next page, but it not support this function in the SQLite. And in the first column is that does not support the create or replace the view. We need to do drop view if exist and create a new view. And if we do not have this clause, when we create a view but it already exists, it will raise an exception. And another problem related to the view definition for the SQLite does not support the naming of view attribute in the header of the create view. So in the Postgres SQL, we will define the view like this. It will follow by the attribute name, but so this is just a convenient shorthand for it. So we will need to change all of the view definition for its form. Then So that are the difference between SQLite and main difference between the SQLite and the PSQL. But if you still want to have a try, you can say the sample solution provided here, so that allow you to practice by your own then. Okay, thank you for watching this video. Bye.